Hello everyone, my name is Yevgen and I hope you're all doing fine. In this video I have prepared a short presentation on the way how we can approach the modeling activities. Basically, it is a presentation on the structured steps which I usually take in order to be able to finish my modeling activities. I think that most of you, or even all of you, have already faced modeling projects and you may have your own steps. But anyway, I thought there might be some interesting ideas and tips which I have in my mind, and I decided to share it with you guys. So let's see if it's gonna work for you. Alright, so let's start with our presentation. As I just mentioned previously, I'm going to talk about the modeling workflow and the steps which I usually take in order to be able to finish my modeling activities. So this is a kind of agenda. Usually what we have goals, we have objectives, and we have modeling subjects, basically the subject on which we are going to work. Then after we set our goals, we are doing the preprocessing. So basically, well, before the preprocessing, obviously we need to gather the useful information, the required information which we need to prepare the model, the geometry, and maybe furthermore for the boundary conditions as well. But anyway, this is I would say that this is the pre-processing. So this is the place where we have to create our geometry, or that might be a case that we can take it from somebody else. It's like from a third party. And then after that, we need to prepare the mesh, and then the solution step, and then after that the post-processing. I will show what exactly, and then the results part. So next slides I'm going to show you, and on those slides I will explain step by step what I usually do. And another thing is that I have to mention that I decided to take a kind of, for this particular project or this presentation, I decided to take an airfoil. This is a NASA airfoil. So for that case, yeah, I will explain and I will show what exactly I did. So we start with goals, and by goals, as I said, I mean objective. So basically, why do we actually need to do this or that kind of modeling? For this particular case, I just invented some objective, and this objective is to define the drag and lift forces on the wing profile at 0 degree of angle of attack and at a certain velocity. You can also add. Then in this case, the modeling subject is in particular this airfoil profile. So basically this is the object on which we are going to perform our simulation. Then we go to the pre-processing steps, as I said. So I would say that for this particular problem, for this airfoil, we should take the geometry parameters. So what is the thickness, what is the length, what are the shapes, all these kind of things. And then we can start preparing the geometry, or we take the drawings or sketches, and after that we do the model. So for the geometry in this case, in order to be able to take this, to prepare this model or this geometry, this is a 2D case basically. And for that I would require these points, this cloud of points. With the help of this cloud of points, I have prepared this shape, this NASA airfoil, and then created a 2D geometry of the fluid domain. After we did the geometry, we need to proceed with the meshing. So with this, we also have to play with the different parameters to check whether the mesh is okay. If we don't have any kind of problems, then we can continue with prescribing the boundary conditions. So for this scenario particular, I had the velocity in the boundary conditions. I applied several symmetries, the pressure outlet, and obviously a wall, which is our NASA airfoil. After we prescribe the boundary condition, then we have to prescribe the parameters of those boundary conditions. So basically for this case, it's inlet velocity, which has to take some magnitude, some value. And after we did all these preparations, we can start with the solution. And the solution includes also several adjustments which we will have today. And those adjustments are related to the solver settings and maybe some other small parameters. For example, user-defined functions, or some post-processing things which we have to do in advance in order to be able to make it smoothly. So these are the steps which are being taken during the solution step or solving step. And after we got the results, we have to post-process them in order to be able to describe, or let's say, to get some outcomes of the problem. So for this case, I took several plots, which is the velocity magnitude on the left, and on the right, the static pressure contours. And also we can create different animations, as in this case. I decided it's a good idea to show how we can use it. So basically these are the vortices which are occurring at the airfoil profile at a certain angle of attack. Basically, if you remember in the objective, I stated like 0 degrees, but I decided just for the sake of nice view, nice pictures, nice animation, I decided to make a slightly different angle of attack. And the results. The results case, well, in my particular presentation, I decided that conclusions might be more than enough. But for results, you can also take as maybe report writing, maybe different plots, maybe some. In the other words, in the results, you have to answer your objective. I mean, if you had some objective, you have to answer if yes or no, and well, if you achieved it, and if yes, then how, and what are the outcomes, and if no, then why, and what are the further steps. And obviously, the report writing, it might be another option. So this is pretty much I wanted to describe in this presentation, in this video. I hope it made a bit structure in your heads, and maybe you can have some steps from here. I appreciate your comments if you have any, and thanks a lot. Have a good day.